Alright guys, so we're going to be solving for the second part of this problem now. Second and third. So what's asking us? It's going to ask for the height, right? So the height the two cars reach after they collide. So first off, we can notice that we already have an initial height, so that's going to come into the factor later on. First off, though, we have to realize something, that this is the velocity relative to the triangle, but it's in a 45-degree, right? So we're going to have the hypotenuse like that, but so when we're going up a hill, we want to find the height, we're not traveling this vertically, we're traveling the component vertically, right? So in order to do that, we need to find the component of that. We're going to get about 16.7 meters per second, and because trigonometry, 45, we're going to get the same on the other side, even though it's not really relevant. So after this, we need to find, so how long is it going to take, how long are the cars going to take to decelerate to reach rest, right? Because that's going to tell us how much time it takes for them to stop moving up, right? So make another triangle. Nothing special. So what forces act on an object when no external forces are acting on it, right? So we got gravity. So we're going to draw the normal force as well. And we're going to get our components of gravity. From this, we can see that it is actually the vertical component, which is going to slow down the car, right? So this component right here is working that way to get the car to go down to the ground, right? So this is actually going to be our force. And we know a nice equation to get our acceleration, right? F equals ma, isolate the acceleration. We know that our force is going to be this right here. And we're going to get that over m. So we see now that the masses of the system, they're going to cancel, right? They're the same. We can cancel them. And from this, we can see that our acceleration or deceleration, acceleration, is g sine theta, right? So knowing our components of velocity going vertically and knowing our acceleration, we can finally find the height which the cars reach. So just pull out let's dust off our kinematics really quickly. So when do the cars stop going vertically up, right? When they reach a velocity of 0 meters per second. So we can just get rid of this. This is just going to be 0. We're going to have negative VO squared equals 2a delta x. Let's just make that a y since we're going vertically. And we isolate our y, delta y. And now we can find how high this is going. So now we substitute our values. Make sure to get the y component. And 2 times g sine and 45 equals delta y. So we can just plug that into our calculator. 2 times 9.8 sine 45. We're going to get about 20.1 meters as the height that we go up. So back again, as I mentioned previously, we have an original height, however. So to do this, to find the final height, we need to get the information that we have and add it to the one that we already know. Equals 20.1 meters plus 800 meters. It's going to give us a grand total of 820.1 meters. Third part of the problem is asking, what is their kinetic energy at the bottom of the hill, right? So using conservation of energy, knowing that the kinetic energy is going to equal the potential energy, they're both going to, we could just draw them next to each other, right? So the kinetic energy is equal to the potential gravitational energy. And we're just trying to solve for the kinetic energy. And we know our potential energy and gravitational energy is mgh. We can now substitute. We know the mass of the system, 7,400 kilograms. Gravity, hold 9.8 meters per second squared. And our height, sorry about that. is going to be 820.1 meters. Now we can just get that in the calculators. We're going to get like 59,500,000. Let's just round off. Joules, of course, the unit of energy. And of course, we know that since we're at the bottom of the hill, all of our potential energy has converted to kinetic energy. So obviously, it's going to be a positive energy. And those are the answers to the problems. Thanks for listening.